All right, so now we're taking a look here. This is the last lesson for this week, lesson 4, and it's analyzing functions using different representations. So again, we'll read through some of the stuff they have written here. Quick thing here, right? Remember, a linear function is a function whose graph is a straight line, right? For example, here, this is a straight line, so it is a linear function. Linear functions can be represented using equations, tables, and graphs. Being able to identify and compare different representations of the same function is a valuable skill to have. So one way to connect a function with its equation is to find some points that make the equation true, then plot these ordered pairs on the coordinate plane. So for example, to find the graph for the equation y equals negative x minus 1, first find the points that make the equation true. So at 0, if we plugged in 0, we'd have y equals to negative 1, right? Then 1, it's negative 2, and so on and so forth. Then we plot these points and we can graph the line as you see on the right there. So the next one here says a company estimates its total monthly expenses to be using the equation y equals 4,000 x plus 4,000. Which graph shows this relationship? So again, if we wanted to make a quick little table here of some points here, we have our x values and our y values. Let's just put in 0 and 1 in here. So when x is equal to 0, we have y equals 4,000, then we could substitute in 0 here, plus 4,000. Well, 4,000 times 0 is 0, so then when x is 0, y equals 4,000. Then, if we want to find the next one, when x is 1, right, we'd have y equals 4,000 times 1 plus 4,000, which is 4,000 plus 4,000, which is 8,000. So these 2 points are going to be on our graph here. So at 0, we're looking for 4,000. So A, 0, nope, it's at 0, not that one. B, 0, not up at 4,000. C, 0, 4,000, okay. D, 0, 4,000, nope, not that one. Then we can double check here. At 1, is our graph at 8,000? At 1, yep, it's at 8,000. That's good. Choice C. Another way we could find this, right, is if we have y equals 4,000 x plus 4,000. This term here, right, is our y-intercept, which is where this graph hits the y-axis, which is at 4,000. Then if we're looking here, this is our slope, 4,000 over 1, means that for every 1 month we go over, we go up 4,000. Over 1, up 4,000. Over 1, up 4,000. Which again shows us it's choice C. I mean, a third way you could also do it is if you put it in your calculator. The only thing is with our thousands here, we're going to have a little bit different looking of a graph there because you'll have to make this go all the way up to 32,000. All right, taking a look at the example. So we're going to skip through here, right? If you want to graph this on your graphing calculator, you can go through and graph that. We've talked about graphing a bunch, but if you need help with that, always reach out and ask and we could set up a meeting to take care of that. All right, let's take a look at sample question 2. Says, Katie and Bethany both earn a commission at their jobs. The function f of x, so f of x equals 0.05x plus 200 represents the total amount of money that Katie makes on sales of x dollars. The graph of g of x at the right represents the total amount of money that Bethany earns on sales of x dollars. So they've already graphed g of x, right? So it starts at 100 and it has a constant increase. And if we take a look here, Katie, if we want to graph hers, starts at 200. And then if we want to take a look over, if we want to try and write this as plot our next point here, I'm just going to pick a point at the end here. Let's put in 1,000 for x and see what we get. So if we do f of 1,000, we're going to try and find our second point here. We'll have 0.05 times 1,000 plus 200. Well, 0.05 times 1,000, right, is going to be, if we move the decimal place over, 1, 2, 3. So f of 1,000 equals, this will be 50 plus 200. F of 1,000 equals 50 plus 200 is 250. which would put us right here. If we connect those 2 points, we can have the line for Katie, and we'll see that these lines are actually parallel, right? They increase at the same rate, right, throughout both of these here. So which statement about f of x and g of x is true? F of x has a smaller slope. So does f of x have a smaller slope? No, it's going to increase at the same rate. F of x has a greater slope than g of x? No, they have the same slope. F of x has a smaller y-intercept. So if we look at f of x, the y-intercept is 200, g of x is 100. So it's not smaller, but f of x does have a greater y-intercept than g of x because its intercept is 200 instead of 100. So it's choice D here, right? So we did that by plotting 2 points. The first one being the y-intercept, which was just at 200. And then the second one, we found out when x was equal to 1,000, what was our y equal to? And it was 250. So our second point was 1,250. All right, let's keep going on here. So taking a look at sample problem 3. So sample problem 3 says that the following function is represented by the table below. So again, we have x, f of x. We have a table here. And then the function g of x is represented by the equation g of x equals 5 over 2 parentheses x minus 2 here. So what we're going to do is let's create a new table for g of x, and then we'll be able to compare and see how it works out here. So x, we want to keep the same, -3, -1, 1, and 3. So if we look here, we're counting by 2 as we go on each step on the x values. And then g of x, to fill out this table, right, we have to substitute in our x values into our equation here to find each value there. So g of -3 is equal to 5 over 2, then parentheses, -3 minus 2. If you work this out on your calculator or in your head, right, you'd have -3 minus 2, which is -5, times 5 halves, which will give us -12.5. Then for the next one, we do the same thing, g of -1. So again, we'll do 5 over 2. Then instead of -3, we write -1 minus 2. So -1 minus 2 is -3 times 5 halves is -7.5. Now we work out g of 1, which is 5 halves times 1 minus 2. 1 minus 2 is -1. -1 times 5 halves, -2.5. Then finally, g of 3 equals 5 halves times 3 minus 2, which will be 3 minus 2 is 1, times 5 halves is going to be 5 halves, which is also 2.5. All right, so when we're looking at sample question 3 here, right now we want to analyze our graphs here, our tables here, to see which one of these is true. So when we're taking a look here, the slope, right, is how much we increase the y values divided by the x values there. So if I'm just picking 2 numbers here, right, so let's take from our first -3 to -2, or to -1. So if we go there, the change in y over the change in x. So from -5 to -3, the change in y was a +2. And then from -3 to -1, the change in x was also a +2. So if we're looking at our slope for our first function, the slope is 1. Now if we want to find the slope for the second function, again, we have change in y over change in x. So we go through these first 2 points again. So from -12.5 to -7.5, we increased by 5. And then from -3 to -1, we increased by 2. So if we're looking at the slope here for the second one, the slope is actually 2.5. So our second function, g of x, has a greater slope than the first function here. Now, if we want to find the y-intercept is going to be the x value when, or the y value when x is 0. So if we're looking at where x is 0, we're looking directly in between -1 and +1. So we want to find the number in between there, which is in between -3 and -1, which is -2. Now, if we do the same thing on this side here, the number in between -7.5 and -2.5 is -5. So our y-intercept for f of x is greater than the y-intercept for g of x because -2 is greater than -5. So if we're looking here, we have the y-intercept for f of x is greater, but the slope of g of x is greater, and that's going to be choice A, which says that f of x has a greater y-intercept, but a smaller slope than g of x. So if you're going through there, you had to find the slopes and the intercepts there. All right, and going on. If we go on, we'll jump down to taking a look at problems that we're going to do on our own. So the first one says, which graph models the equation 2x plus 3y equals -6? Now, when I see a graph like this, if you have your nice calculator up, you can put this in as a relation and it will graph it. However, I want to solve this for y so that we can just look at the slope and the y-intercept. So if I have 2x plus 3y equals -6, if I want to solve this for y, first thing I'm going to do is subtract 2x from both sides. So then I'll be left with 3y equals, and we're just going to write this next to each other, -2x minus 6. We can't combine them, right, because they're not like terms. So now to get y by itself, we're going to divide both sides by 3. And we need to divide each term by 3 on the right side. So we'll have y is equal to, I'm going to leave this as a fraction, -2/3 x, then -6 divided by +3 is -2. So if we're taking a look at our graph here, we have our y-intercept at -2, and then we have our slope, which is down 2 to the right 3. So if I'm looking to start, I want to go through the y-intercept. So y-intercept at -2. For A, y-intercept is at -2, good. B, the y-intercept is at -3, not our answer. C, y-intercept at -2, good. D, y-intercept at -3, not our answer. Now we have a slope of -2/3, which means that it's going to be a negative slope or going down. If we look at line A is negative slope going down. So this is going to be our answer here. Line C has a positive slope because it's going up. So here, if we look at A to get from this point here, if we go down 2, 1, 2, and go over 1, 2, 3, we're still on our line, which shows that the slope is -2/3. So it is choice A. Continuing through here. Number 2. So number 2 says, Tanya and Vera both design and print t-shirts. They each have a fixed cost for equipment to print t-shirts, and they each also have a supply cost per t-shirt that they print. So I'm going to move this over a little bit. We're going to take a look here. If Tanya has $3 per t-shirt she prints, that's how much it costs. The total cost for Tanya to print t-shirts, 60 t-shirts, is $260. So for starting off with just Tanya, we want to find out how much it costs per shirt, right? And we want to find out the cost for equipment, right? The equipment cost. So in this one here, they gave us how much it costs per shirt. So for Tanya, it costs $3 per shirt. Oops, $3 per shirt. Now, if we want to find the total equipment cost, what we're going to do is take the total cost, right, that she paid, which is $260, and we're going to subtract from it how much we know she pays per shirt. So she pays $3 per shirt, and then this $260 was for 60 shirts. So in parentheses, 60 shirts. So we'll have 260 minus 3 times 60 is 180. So 260 minus 80 is going to be $80. So that means that her equipment cost here is $80. Now we want to take a look at Vera's printing cost. So now we have Vera, I have her in red down here. So Vera, so we did not get how much it costs per shirt or the running cost. So what we have to do is find our average rate of change here. So I'm just going to pick our first 2 points here, and we'll find how much it increases per shirt that increased, right? So this will be our x1, y1, and then we have x2, y2. So we'll start by finding the slope. So let me just actually write cost per shirt, and then equip cost. So we'll start by finding the slope here, or the rate of change, to find the cost per shirt. So we take y2 minus y1 over x2 minus x1. So this is equal to y2, which is 350, minus y1, 150, over x2, which is 75, minus x1, which is 25. 350 minus 150, 200, over 75 minus 25 is 50, which leaves us with 200 divided by 50, which is 4. So her cost per shirt is going to be $4. So now, if we want to find the equipment cost, we do the same thing we did over here, but with one of our pieces of data here. So now let's pick our first one again. So we're just looking at the X value there and the total cost. So the total cost was 150, but then we want to subtract from it how much it costs per shirt. And it cost, right, when we're looking here, it cost $4 per shirt. And for a total cost of 150, she had 25 shirts. So now we go through and just work this out here. So this is 150 minus 4 times 25, which is 100. 150 minus 100 is $50. So the equipment cost that she pays is $50. So now if we're comparing these two pieces of data, right? We have Tanya and we have Vera. Tanya costs $3 per shirt to make, but her daily equipment costs $80 to run. Vera costs $4 per shirt to make, which is more, but her equipment cost is less. So if we're looking through here, A says Tanya has a greater supply cost and equipment cost. No. B, Vera has a greater supply cost and equipment cost. No, because they each had one that was greater and one that was smaller. Tanya has a greater supply cost. Remember, our supply cost is per shirt, but a smaller equipment cost. No, because her cost per shirt is actually less. Vera has a greater supply cost, which is per shirt. So 4 is greater than 3. Good. And a smaller equipment cost. 50 is less than 80. Yep, than Tanya. So our answer here is choice D. As we go through here, take a look at number 3. So number 3 has the functions are shown below. We have f of x equals 3x plus 6. Here we have a table with x and g of x, and then we have a line h of x. So if we're looking which statement must be true of these functions, well, they all have to do with slope, 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 slope. So let's find the slope of each of these functions here. So the slope of f of x, right, is just the number in front of our x. So m is equal to 3. When we look at the slope of this function here, we want to see how much does it change as x increases by 1, right? So this is our change of y over change of x. As x increases by 1, y goes from 6 to 9, which is 3. So our slope is 3. And then on our line here, we take a look at 2 points. Our slope, right, is our rise. So we went up 1 over 1. So for h of x, the slope is up 1 over 1, which equals 1. So our slopes are 3, 3, and 1. So does f of x have the greatest slope? No, because g of x is the same. H of x has the greatest slope. No, because h of x, the slope was 1. G of x has a smaller slope than f of x. No, they are the same. D, h of x has a smaller slope than g of x. Yes, that is correct. because h of x, the slope is 1, and that's smaller than g of x, where the slope was 3. All right, taking a look, we got 2 problems left here. This next one says, graph the function f of x is equal to 2 parentheses x plus 1 minus 5 on the coordinate plane. So if we're going through here, I'm going to simplify this function so that it's in slope-intercept form so that it's easier to graph. So if I have f of x equals 2x plus 1 minus 5, I'm going to distribute the 2 to remove the parentheses. So x equals 2 times x, which is 2x, then 2 times 1, which is 2, then we have minus 5. Then we'll combine our like terms, which is our positive 2 and our negative 5. So we have f of x equals 2x. So when we're going through here, 2 minus 5 is going to be negative 3. So we put a point at 0, 1, 2, negative 3. Then we have our slope here, which is 2, or 2 over 1. So that means we go up 2, 1, 2 over 1. Up 2 over 1, up 2 over 1. Then I'm going to use my line tool here just to connect a line that goes through all those points there and then continues on. Then we could actually extend it going on down here as well. So this is our function, f of x. Okay, so it says, what are the x and y intercepts? So the x-intercept is going to be right here where we cross the x-axis, and that's at the point 1.5 and 0. And then the y-intercept is right here where we cross the y-axis. Also, we found it over here, which is 0, and the y value of negative 3. So for this one here, we want to solve the equation into y-intercept form, make it a little bit easier to graph on the coordinate plane here. All right, so our last one we're taking a look at says Gavin and Rosie each planted 3-foot-tall trees in their backyard or in their yards on the same day. They each recorded the height of their tree each year for the next 5 years. These data are shown in the graph in the table below. So we have Gavin's tree and Rosie's tree. Rosie will graph her data on the same coordinate plane as Gavin's data. Compare the steepness of Gavin's line to Rosie's line. What does this tell you about the trees, the rate at which the trees are growing? So what we're going to do is take a look and plot Rosie's on our same graph that we have here. So at year 1, Rosie's was 4.75, right, which is right about, so if we're at 4, about halfway is 5, so a little bit under 4.75. Then at 2, it's at 6.5, so again, we're about a quarter of the way through there. Then at 3, we're at 8.25, so a little bit above 8. At 4, we're up to 10. And then at 5, we're up to 11.75, which is almost up to 12 here. So if we were to create a line by connecting these points here, right, they both started at 3 feet. But if we take a look, Rosie's line is above Gavin's line, and it's increasing at a greater rate, right? Because it's a straight line, but it's going at a greater rate. So if we compare the steepness of Gavin's line to Rosie's line, what does this tell us about the rate at which the trees are growing? We could say that Rosie's tree is growing at a greater rate because the line has a greater slope, right? Its steepness is greater, the slope is greater, so it's going to be increasing at a greater rate. All right, so that is the end for lesson 4. So make sure you go through and you put in your answers that you had throughout the multiple choice into the quiz so you can be earning as much points as you can before this year is over. If you have questions, like always, make sure to reach out and we'll get back to you with some answers.